Okay, we're on. Hi, thanks for coming. This is 20 Modern Visual C++ Practices. My name is Eric Battaglio. I'm a program manager with the Visual C++ team. I spend most of my time working with communities and spending time with folks like you, learning more about how C++ is used in enterprises and indie shops and the spectrum between, and figuring out how we can improve the product and the product itself, and then the story around the product, which means information, scenarios, supplementals, examples, and things like that. My email is there. I love email. The team is very responsive. So if you have any technical questions or any general statements, feedback you want to share, please do send it to me. At TechEd North America, we had someone come up afterwards and ask about an optimizer problem, and followed up with an email. We actually sent that to the optimizer team, and we're working with them on that specific issue. So we do respond. Please do send an email if you have any kind of feedback. So does anybody know what this is? So if you're familiar with the site Reddit, there's a subboard there for C++ programming, and the question was, if there was a mascot for the C++ programming language, who would it be? What would it be? This is one of the proposed mascots. It's Judge Dredd riding a T-Rex with an RPG on a fire-breathing shark. It's a testament to the allure and danger and power of C++, and I thought it was really kind of funny, and included it here as a nod to native developers. Before we begin, this is a 300-level session, but if you're an expert, it may seem 100 level or 0 level, depending upon how long you've been doing this. And if you're new to C++, some of it will seem more advanced. I'm not an expert in C++, so some of the concepts were a little advanced as well. Parts seem 500 level to me. Some tips require Visual Studio 2012. Language-specific tips are typically compiler agnostic. This presentation was generated from the community, people like you and our MVPs and influencers and just people out in the community. No developers were hurt in this process. The thing that I've learned, before I came to the C++ team, I was working in the IT pro space, and what's interesting is coming back to C++, I was a hardcore C programmer back in the day with some C++, is writing programs and then having them looked at by the Visual C++ team, the developers and PMs and things on the team. For every person I asked, I got yet a different view on things even as simple as counting words in a file. Should I use a map? Should I use, what specific construct should I be using? So what this slide is C++ is expressive. There are many different correct ways to do something. It's okay. Choose the one that's best given the constraints that you have, and provided you don't break some of our tips as well. So code clarity, make sure you express your intent. Feel free to share your experience during this session. If you have some experiences that you would like to share during or at the end, if you've got some extra tips, please do share. I know TechEd North America, there were a couple people that came up and had some tips that they shared. So I've got 20 practices. This is number 1. Write code for other developers. Code for the next developer. So as a C person, I remember reading Code Complete back in the day. This was in the 80s. And the guidance hasn't really changed much. And I'm going to say that again later, that some of the guidance here hasn't really changed from 20, 25 years, probably even 40 years. Avoid superfluous comments. Explain why, not what. So in this particular example, we're not saying if, the age is less than 16. What we're saying is this is a HIPAA requirement. So there's a healthcare law out there that we're handling, and that gives a little bit more background. Avoid formatting wars, the 80s called. This is something else that I remember back 20 years ago, and I think it's still, I was surprised to hear from the community this is still a thing, that, do you put the braces on their own line? Are they staggered like this? Do you have a space after the for loop? There was a bunch of questions out there, The answer is you just pick something and run with it, right? And I know back in the C days that some folks, some of the developers I worked with were hardcore enough that they got a code reformatter. And they just formatted the code they wanted, and then before they checked in, they ran it through a formatter, and then vice versa. So they were that hardcore about it. I don't know if I'd go that far, but just pick a format and go with it. So Stefan is on our team. What's funny is I actually wrote code with the if statement like that, with no space between the F and the parenthesis. And Stefan said, if it's not a function, I strongly recommend putting a space after it. People who don't are bad and should feel bad. And Stefan's a funny guy. I don't know if many of you track some of his Channel 9 activity and his posts. He works on the standard template library, and his initials are STL. He's very good with C++, and this is just one of the pieces of feedback. And I think he's right there. It made sense to me. But I'm not immune to any of these tips either. And oftentimes, if I'm blogging about this stuff on the VC blog, I get, everybody sees, right? I share the comments like this because it's kind of funny that, some of the people that work at Microsoft are just regular people and aren't experts. That's me. Understand what you have written. Keep it simple. Excessive complexity hides errors. Functions should do one thing well. Again, this is guidance that has been out there. When I was working a booth and interacting with customers a few weeks ago, we were talking about some of the tips, and I said, I find it hard to believe that this is, simple code, short functions is still something that we would have to mention. And this person, I'm not kidding. This person said, oh no, we've got this legacy code base, and there's a function in this code base that's got 10,000 lines in it. And I couldn't believe it. And this story was repeated a few times. There were other people that came in and said, I've got legacy code base. We've got in excess of 3-4 million lines in this application. And some of the functions do have more than 1,000, 2,000, 3,000 lines. That seems crazy to me, but there's a lot of big legacy applications out there. I would hope that if people are writing new applications, that isn't the case. If you don't know why it works, that's a bug. I wrote this code. I happen to know what it does. It's twiddling some bits to get a mask for something. But if you don't know what you just wrote, it's a bug. And it's kind of funny. I'll relate this back again. No one in particular. But back when you're first learning a language, when I was first learning C, C++, a lot of times I would copy examples and not really know how they worked, but they worked. And that's a recipe for disaster down the line. That, in some cases, for some simple things, it might work. But for more advanced things, you might not understand static cast or all the weirdness that comes around with static cast, or really any API function or weird incantation that you might utter. So here's some signs of questionable code. These comments. And these are real comments. Most of them are. Here there be dragons. I'm not sure if we need this, but too scared to delete. That's an interesting problem because I don't think I would delete anything that had that either. And that kind of code just accrues like, black mold in your house. It just accrues. You don't know, you know it's there. You're not really sure what it's doing. In case of mold, I guess you do. Please forgive me for what I have done. That's one of my favorites. And then I'm thinking, in 20 years, are people going to look in code and see this? For those of you that follow Game of Thrones. Prefer automatic resource management. Use a stack. So in this particular example, we're creating an instance of a platypus. It's Perry. He talks. When the function exits, it's cleaned up for you. In this example, we've got it at the class level. And same, you get the same kind of cleanup. No naked pointers without ownership. So in this example, this is old school. I'm creating a new platypus. This is not what you should be doing. In this particular example, I know it's going to be a unique pointer, so I use make unique. And then I use Perry, and then when it ends, it goes away. One of the things I learned while I was, once I got this example from the community, I went and did a little bit of work. Make unique is actually, if you're going to have a unique pointer, prefer make unique. Standard make unique. It's efficient. And if you're going to do a shared pointer, prefer make shared. It actually is more performant if you do that because the internal mechanisms that it allocates memory for are going to be contiguous. So that's just a side thing. But again, use make unique if you're going to have a pointer, and then later on, if you need to change from that, change it with more knowledge. Considering updating old code, of course, there's risks to this. If you update it, you don't have a good comprehensive test suite for that code. You may not know if you've broken it, right, when you're fixing it or changing it. There are also rewards. If you've got a lot of naked pointers and you switch it over to things that smart pointers, then you potentially will get rid of leaks and other perilous conditions. And you have to decide. And I've talked to some folks on the team. There's a guy, James, who manages the library code for Visual C++, and he has to balance this. There's code out there. He said there was a bug, a message in the code that was older than he was, and this message says it was dated and it's older than he was. So you have to really be careful when you go out there, and if you're going to be in the code anyway, changing it or fixing substantial blocks, then you do have an opportunity to upgrade it. Const is usually the right choice with state vals and instead of defined. So Kate, she's an MVP. She also wrote the C++ AMP book, co-wrote that book. It's a great book. If you don't have it, you're interested in performance, then I would recommend you get it. You shouldn't use a define anymore, right? C guy comes kind of hard. In this example, we've got a constant at the class level, and in the Direct 3D Windows base, I stole this code from a 3D kit. We've got the static const actually specified right about where it's used. And again, that's generally the format that's preferred. You specify it where near it's used, but you could certainly put it somewhere else. And it's just good practice, right? And it's expressing your intent. This is all about intentions. You intend for these things not to change, so use const. When the function doesn't modify visible state, so in this example, we've got get area. So once you've set the size of the triangle, the area, it's not going to change, right? It's going to fix. So while you're caching it internally, and that internally the state is changing, from the consumer, from the external perspective, it's not. So go ahead and use const. I've mentioned this, express your intent. So in this example, we've got a forward declaration of int f, and then we've got the definition itself. The definition actually uses const, but the forward declaration does not. The compiler will ignore the const in the forward declaration. In the definition itself, since you intend not to modify the I, then go ahead and specify const there. This compiles just fine, and it does express your intent. I is a const. So for more information, and just if you want good reads, I mentioned Stefan earlier in Channel 9 and some of his posts. He's got lots of things out there. Herb Sutter is another one that I have a point to his Guru of the Week post there. There are a lot of things on his site where he describes just best practices from an abstract level. Herb is on the standards committee, the ISO C++ standards committee, and he's also right down the hall from me, which is nice. I can go down and ask questions. In fact, a lot of these folks are just right down the hall, so I can go right down and bug them. So definitely follow up on that site if you're looking for more information. And then avoid when necessary. I added this one after talking to the C++ CX guys. If you're going to be writing a WinRT component, your class cannot actually have a const on it. So the way you get around it is you have a static, use a static property. And the code will look something like this. So some rules you have to twist. Range 4. Use range 4. Familiar with this? Again, it's all about the intentions. So range 4 is a more concise way to have a for loop. In this particular example, we've got a vector, and we want to iterate through each of the elements in the example. Now, there's 95% of the cases, there's one of two things you're going to be doing. You're going to be visiting each element and then modifying it, or you're going to be visiting each element and just looking at it, observing it. And these two cases are covered here. If you intend to modify it, use auto-an e. And then if you're not, use const auto-an e. This is going to get you 95% of the time. This is the right way to go about it. What about the 5%? You need to get specialized. So if you intend to copy, that first one is a good example. If you intend to copy, make sure you intend to copy though, right? Otherwise you're killing performance. If you intend to convert, that was one I hadn't seen before. So if you've got a bucket of int32s, unsigned int32s, and you want to upconvert, then this is an example of where you would do that. And then when proxies are involved, you've got that syntax at the bottom. And when would there be proxies? When you've got a vector of bools, for example. You cannot get a direct, the internal representation are bits, and you can't really get a direct reference to a bit. So there is a proxy involved, and this code will work just fine for you. Don't help the compiler. Compact source code doesn't equals compact executable. This is, again, I was really surprised when this popped up in the community as a suggestion, because it felt kind of old school to me, as harkening back to C. It just seemed old school. It also harkens back to Apple 2GS era AppleSoft. So this is an example of some code that we were conditioned on, that if you want to display a high-res file, that's what this particular thing does. There's a 2-line program that will do it. And there were reasons. It was fun to write code like this, but there were some limitations of the interpreter such that if you wanted to get lots of code in, the tokens, you had to shove a lot on a line. So some of us were conditioned that way. You don't need to do that, obviously, right? In fact, a lot of times, if you've got expressive source code, the optimizer is going to better understand your intent and make better code. Like Leggings and Loverboy, this went out with the 80s. So pointers can hinder optimization. In this example, and this is a canonical example, so I didn't make this one up. This is one where the optimizer guys use that. And Jim Hogg is one of the guys on our team that has some content out. In fact, there it is. Take a look. He works on the vectorizer and has some content around this. In the first example, people think it's going to be fast because of the pointers, but the vectorizer can't handle that because it doesn't necessarily know what the pointers are pointing to. In the second example, it does understand what it's pointing to. So it will be fast because of vectorization. So again, express your intent. Profile later and optimize after that. So premature profiling and optimization has been said by a number of different people, is kind of the bane of good coding, right? You should almost be complete with your application before you optimize, and only optimize after using a profiler. You can nudge the compiler as needed. There is an example out there in this particular one. We're doing some work here, and the optimizer is not going to be able to figure out that it can do anything with it. In this example, you can use hint parallel and tell the number of threads that it should use. There is more information about this on Jim Hogg's in his content, so I would advise you to go out and take a look at that. But again, all these rules are not they're not all written in stone. There are some times when you may need to sidestep them, but make sure that you're aware of that you're sidestepping them, right? And that's the idea here. Know your compiler options. You guys know compiler options? Any favorites? Which one? Oh, nice. So that's exactly what folks should be using is compiler warning level. Use this. That's what people in the community said. There's some other ones for whole program optimization. That's a popular one. FP fast, if you want fast floating point. WX, treat all compiler warnings as errors. That's another good one. But if you've got a 3 million line legacy program and you turn that on, that's probably not something you're going to want to do, right? If you turn W4 on that code base, there's a good chance you're going to get just an unmanageable number of warnings. So be careful with WX. Compile in parallel, that was someone on the compiler team mentioned that one, so we added that. And then, again, if you want more information about what was auto-parallelized and auto-vectorized, you can use those switches and then go out and kind of parse through the log files that you get. And there are 2 posts for more information if you're interested in this. I love this one. James, someone at Microsoft, actually said this was his favorite. Kidding, of course, the FU, and that is used for a special case there. So thanks to James for that. Standard string is also a container. Avoid rewriting stuff in algorithm. So string, you can count spaces using things from, like isSpace using standard count. You can erase things with things from like standard erase, remove if, and then you can reverse with algorithms outside of the container itself. So if you're going to write a container class, make sure that it's about the data, and then things that operate on the data you don't necessarily have to have as members of your class. It's also a user-defined type. So this code may not seem obvious at first, but when you call AA with what is printed, it will print wolf, because a car star will not be converted to standard string. It can be converted to a Boolean. So this is not something that people catch. And if you think this is a contrived example, what's funny is late last week, before the end of the week and before flying out here, on an internal alias, there was this issue came up. There was a question asked around this very thing. So remember that. Use strongly typed enums. They're type safe. The old ones weren't. So in this example, we've got agents, Perry, Bond, James Bond, and we instantiate an instance of agents. And we can have an underlying type, user specified. Anybody know who Sir Hugo Drax was? James Bond. Which movie? Moonraker. Absolutely. It can be forward declared as well. Here's some examples of that. And they're not scoped to the enclosing scope. So you can have, you can specify which ones. You can actually have two different namespaces with two different, like agents, for example. You could have scope to two different namespaces, and they can be different lists. With non-strongly typed, it was a lot more uglier. Wait, before I go. If you're taking a look at older code, one of the crimes that people like me used to do with enums is we'd have bit masks on them, bit flags, right? And then we'd go out and use those as just literals and then go monkey around with bits. That's probably code you're going to have a little bit more trouble upgrading, right? So there may be cases where, just for whatever reason, you're not going to want to bring that code forward. Consider non-member functions. Apply the interface principle. Interface principle? Yeah, there's someone. So in sum, for class X, all functions that mention X and are supplied with X are logically part of X. An example of that is you have a class, X, and the question is F part of X? And you'll see at the bottom here that if you take a look at class X and F is really the operator out, then you can kind of logically see that even though that operator is not a member, it is part of that class, and it's considered part of it. And it's related to Koenig lookup. When I first ran through these slides with some folks, I didn't have this, and they said, what about Koenig lookup? You have to mention Koenig lookup. So I'm mentioning Koenig lookup, and the idea around that is in a function, the types that are passed to a function call, the arguments, the compiler will try to resolve those in the namespace of the type itself. So it's going to look up in the context and the scope and then go all the way back to where the name, where the item itself that was passed in, one of the arguments, was defined, and then try to find a match there as well. That's the idea around Koenig lookup. There's more information out. Again, Herb Sutter has a nice comment on that. So container stored data, algorithms perform operations on them. Standard vector is a good example, and then you sort using something else. For C people, if there are C, old school C folks in the room, or new school C folks, qsort is a canonical example there. Yeah, it's kind of like qsort. So I'm mentioning Herb again. Herb is a prolific writer, and he has some great content on this. Again, the community also mentioned Herb. Use lambdas. Anybody know what this house is? Anybody know this house? I'll give you a hint. It's 80s. It's a movie. Which one? Oh, I had to credit it, though. All right. Someone guessed it at TechEd North America. I guess that's why. So yeah, it's Revenge of the Nerds. Nice catch. So lambdas are not just for nerds. Use explicit capture. If you use general capture, you'll have access to a lot more. but you can get in trouble that way. So again, state your intentions, right? If your intent is just to use I, then just capture I. Avoid circular references. This is something that you'll get in with C++ CX. So if you're not using C++ CX, it's less likely to happen. But basically what happens is you have a lambda that's handling an event, a UI event, and if you don't weak reference this, then what will happen is it'll pass this into the lambda and then hold on to it, and you'll have a circular reference and you're in trouble. And there's more information on that link. And then use auto for return values. In general, this is what you're going to want to do. Auto is one of those things that, some people say you should use auto for everything. Some people say you should be very careful in where you use auto. I go back and forth. If the environment will tell me ultimately what the auto is, like in this case is lucky, then I have a good sense of it. But part of me feels like it's not stating my intent clearly enough. So if I know that this is going to be a Boolean return, then why can't I just say bool is lucky, right? And then I state my intent. And if it changes in the future and I'm unaware of it, it'll break the code here. With auto, it wouldn't. And part of me would like to know if something changed so drastically that my assumption there has changed. So regular expressions. They're superior to handwritten code. Simplify control flow and move the description into something that's well documented, right? So that's really one of the big benefits. If you're going to handwrite code to do token parsing and things like that, you'll have to make sure that your code is very clear and you'll comment it. If you use regular expressions, I can go get a book on that. If I don't understand your specific incantation, and there's a good chance I won't, depending upon what it does, I can either cut and paste that regular expression into a visual parser and see what's going on, or go grab a book or some combination of that. So that's really the big benefit there. Closer to the problem domain, abstracting away code complexity. And then intricate expressions are much easier to read than the underlying code. And again, I've name dropped Stefan before. He's got a great session here on using regular expressions. So there's a link. And then here's some examples. I'm sure these are relatively common. So we're going to search for a comment in the first one. On the second one, we're just looking for something that looks like a dimension. Yes? Are there cases where you wouldn't use regular expressions for performance reasons or complexity? There are some cases. I would say that if your profiler is showing that you're spending a lot of time in a regular expression, parsing it, and an inordinate amount of time, and you think you need to optimize it, then at that point I would consider going with a handwritten, trying it and see if the handwritten one is better. The one concrete example I saw was in the case of processing, trying to figure out if you have a valid email address, right? You're validating an email address. And the first ones was, it's about this long. And then there was ones that, it kind of expanded over time trying to get this thing right. And one wag out there on Stack Overflow said, well, it's just easier to take the address and then try to send them an email, right? And if it fails, then it's not a good email address. That's the only way you'll know. And it was like, yeah. So in a lot of these systems, that would be sufficient. So that's another thing that you can kind of balance between, is it a very difficult problem you're trying to solve, and then maybe there's just a different algorithm altogether. So number 12, the namespace trick. Using full namespace qualifiers is ugly, and depending upon what kind of development you're doing, this can get really ugly. So if you're using like C++ and XAML, you're pulling in a lot of namespaces, it can get verbose like this. What you can do is you can map all of the namespaces that you want to use into a single namespace in one place, and then get consistency and symmetry and eliminate repetitiveness. So, the bottom one is arguably much easier to read, provided you know what the win is, right? And you can name these descriptively, something that better suits your problem domain. But it's something that, again, someone internally, James McNellis, had pointed out. And someone from the community, MVP, said, well, I use this trick all the time, and they're the one that submitted it. So it's just, I had never heard of this until it was submitted, and I went out and took a look. Yeah, I can see why this makes a difference. Number 13, most of the time, standard vector is best. It's the hardest working container in standard library. This is another one of those things that, it can be controversial because people will come out and say, well, it's not performant, or it doesn't work in my specific case. For a sequence container, though, there isn't a reason to use anything else. There are, if you go out and take a look, there is evidence that people have compiled that say, look, the performance is going to be fine. There are cases when you might need, a DAC or something else, but in general, the performance is going to be fine. And it uses contiguous memory, so that helps. I know that's an implementation detail, but it uses contiguous memory, and that's one of the things that contributes to its speed. And then you can see here that I went out and found, what kind of time we're talking about for doing some of these things. Usually constant time. There's linear time if you're going to be erasing. There are cases. If you take a look at vector class, there is more information out there that if you think you need something specialized, then you're probably at a point where you understand the problem a little bit better, and you can stray away from vector. But again, if you just need a collection, a sequential container, standard vector is a good way to go. Anybody tried profile guided optimization? So what is profile guided optimization? It lets you use real world data and use cases when you use your application, and then when it takes data, it collects data, and then when you go back to compile, it sees that real world scenario data, and then compiles based on the targets that you've set for it. So how that works is you instrument first, and then you would train, and then you would optimize. So when you instrument, it's a linker switch. And then when you train, you're just running the application. It's a profile. And then at the end, you'll tell it to link with the data that it found. And it's used today to optimize all sorts of things, operating systems, browsers, legacy applications. And what's interesting is it varies how big your source code is. It can work on smaller things, but generally a little bit larger code base works well on. So if you've got legacy applications and you're using Visual Studio 2012, you could give it a try, and maybe your application for free, you can get some performance increase there. It works with desktop store apps on x86 and x84 platforms. And there is a walkthrough on the blog. So hopefully you've noticed a lot of the content, a lot of the ideas that we have here, I've tried to anchor back to concrete information out on the internet, mostly on VC blog, but some of the other things that people have posted as well. If you're interested in Pogo, definitely take a look to Build, which is started today. It's this week in San Francisco. Look to streaming site. I'll have a link. We have some announcements. The Visual Studio, there's some announcements there. And if you pay attention, maybe there's some information on this as well. So this one came up. Someone said, learn synchronization. We live in a multi-core world, and it's just a fact of life. So you need to learn synchronization to be an effective C++ developer. So I took a look, and I was trying to figure out what the 1 or 2 or 3 points that I need to have to kind of get you started here. And I started asking around, and these are some of the responses I got. Synchronization is hard. Consider a different algorithm. You don't need synchronization. Just pick a different algorithm. Avoid it that way. Well, your app isn't really slow. Why would you need synchronization? Just leave it the way it is. Again, avoiding the problem. My favorite. Use some other language. It's easy to do there. It just works for you, right? Just go do that. And then there's a bunch of other ones. You really only need it for UI work. Whenever possible, avoid shared mutable state. That one's something you can run. Design so you don't need it. And then, I talked to some folks. I think the better advice here is, beyond what I could do in a slide, is Anthony Williams' book, C++ Concurrency in Action, is a good one. And then The Evolution of Synchronization. Kenny Kerr, that is actually on MSDM Magazine in the last few months, so definitely take a look there. And then, for those CS computer science people, Operating systems, it's one of the classics, right? I just pointed out the third edition here. Take a look there. I know that Lucian Wilczek has given some sessions here using managed languages and asynchronous, but a lot of the principles there transfer. So he's already given 2 talks, and I think his other talk is either tomorrow or Friday. So in your guide, take a look for asynchrony and asynchronous, and he has a session on that. Exceptions are your friend. Use the strongest guarantee you can. So the basic is, if there's an exception, your object is left in some state. You might not know what the state is. In fact, the state isn't guaranteed, but it's left in some state such that you can destruct it. For strong, you've got commit and rollback semantics. So if something bad happens, you know that you're left at the state that you were in, and kind of collateral damage is minimized. And then the no throw is the strongest, will always complete successfully, so it will not throw. And you should try to use the strongest one you can. Obviously, no throw is preferred. Here's a great, this Lessons Learned by David Abrahams. It's great. I would, you can learn a little bit more there, but I do use them deliberately. Don't use a control program flow. This is another one of those things that I was surprised, because back in the day, and using even things like C# and Java, you don't typically want to throw an exception just to, when you're done reading a file, you throw an exception so it leaves a loop and then puts you somewhere else. I was a little surprised that this is something that explicitly came out from the community. It's like, wow, really? I'm a little surprised, but don't do that. Distinguish errors from not errors and avoid error codes. So, in this particular example, this is from some code I wrote. It's looking for some inputs, and if there's a combination of inputs that it doesn't recognize, it actually throws. That should never happen. So it is exceptional, and if it does happen, it makes you almost wonder, is the machine melting down or something? So it's a weird one. Note that I don't have anything up there that says don't. It was easy to ignore basic things with return codes back in the day. With C, it's I'm going to return -2. Fine. When I call the function, I'm not even capturing it, so I don't really care if it succeeds or not. I just kind of go blissfully unaware and onward. It's just as easy with exceptions if you want to, right? You can catch just ... and ignore everything if you want to, and I've seen programs that do that. What you want to do is try to catch what you can handle, but don't catch what you can't handle. So in this particular case, if there's a zombie invasion and there's hordes of zombies coming, what are you going to do with it? Are you going to drive to California? He wasn't even a zombie. This part that wasn't fair. So 17, use assertions. Use at runtime or compile time. There's 2. You can assert for runtime checks. In this particular example, we have a DirectX MVP, someone who does a lot of DirectX programming in 3D games, 3D programming, that you can assert to make sure that some of your angles that you're feeding in don't fall out of a certain range. That's really helpful for debugging graphics, and this is something that saves him a lot of time. So that's a concrete example of something that you do at runtime. And then at compile time, you can make sure that you're running, when you compile, that it's compiling for the right number of the right bitness. And then if you're a template master, which I am not, if you're writing some sophisticated templates, you can catch whether something should be a plain old data type. There are a lot of other things that you can do. I've got more examples here. Again, I am not a template expert. And when I talk to folks about that, a lot of times the most sophisticated features like variadic templates and perfect forwarding, these types of things, while it's interesting to be aware of them, unless you're writing libraries, you typically don't need to use them, right? Or at least the more advanced features of this. So someone like Stefan, who's working on this, does need to worry about that. Someone like me that's just using standard vector typically does not need to worry as much about at least templates. It's not going to appeal to your vanity. More assertions and code verifications means fewer bugs. So this is from Microsoft research. Software engineers who were able to make productive use of assertions in their code base tended to be well-trained and experienced. So if you use assertions, you're well-trained and experienced. You should just Put a sticker on your back. I'm well trained and experienced because I use assertions. So I just thought that was funny, right? You can find evidence out there to kind of make yourself feel good about some of these things. So that was funny. People have read Code Complete and the Mythical Man Month and Death March, those types of things. There are a lot more, there are a lot more like stories around this. If you haven't done that, they're almost war stories and stories from the trenches. You should go back and read some of these books. They almost border on the narrative, but it will make you feel good sometimes about maybe some of the coding you've done and some of the weird things that you've had to solve. And some of them are a little old. They have been updated, but it's definitely worth your read. Even if it's using C, you don't use C anymore. There's some good examples out there, and it's just fun to read. So we're at number 18 now. Find something new in Visual Studio. Use Visual Studio? I assume some of you do. Yeah. There's a lot of things in Visual Studio that you may be unaware of. If you were fortunate, you attended the talk earlier today on Visual Studio tips and tricks. It was a general perspective, not necessarily geared specifically to C++. What came out when I was asking the community about their tips is the ability to use multiple monitors. Visual Studio supports that. One of the neat things that it will do is you can create multiple solution explorers. So if you've got a big project, you can actually drill in on the Solution Explorer, right-click on a sub-project, and then say pop open, and it'll give you a view just on that. You drag that to the other monitor, and then you've got 2 different views on the same solution, which is kind of neat. I didn't know that. I also didn't know that you could hit Control to temporarily hide IntelliSense. Control-J will force it on. What I found out on the bus coming here from the Visual Studio tips and tricks guy was Control generally works with anything that pops up like IntelliSense. So if you're doing like a data explorer and debug and this data visualizer is huge and it covers up your code and it's kind of in the way, you can hit Control, it'll fade to the background so you can see your code, and then you let Control off, it'll come back. It's pretty handy. And then Quick Launch finds everything. The Navigate to dialog is something else that people generally use. And then, because I'm on the Visual C++ team and we get a lot of haranguing about this, you can change the theme. There is a tool out there to change it. This Visual Studio itself will let you switch from, I think, the black format to something that's more what the older ones look like, which is white background. People are very territorial about their Visual Studio environment. And what's interesting about that is it's just, as a community person and someone who develops, it was kind of a duh thing. It's like you mess with someone's environment and you're going to get trouble. It's not an environment that people use for 20 minutes. I mean, when you're a developer, you are typically in this for 8 hours, right? 8 or 10 hours. So it is something that you live in. And if we get it wrong or we change something and it's not clear what we've done, then you get a lot of pushback. I think the other thing that's interesting is we tend to fall into our habits. So if you came, I'm dating myself here, but if you came from something like one of the Turbo products back in the day that uses WordStar-like functionality, Control K, Control C, those types of things, that tends to keep your tunnel on. So the functionality that you expect in a Visual Studio is somewhere along the same lines. I'm just doing basic stuff. It's kind of interesting for you to spend some time, maybe the next time you have lunch or you've got some 15 minutes or something. Go out and just to start exploring what else is in Visual Studio, what other kind of commands can you do. There are a whole lot of things out there that'll let you do, including copy a column, right, which is something I used to use an external editor for when I'm just copying columns of information. So definitely spend some time there. Anybody have a favorite tip in the room? Visual Studio. Well, there are a lot out there. Definitely recommend you do it. This is the first one that popped up. This is the first suggestion, and it was third and fourth by folks in the community. Stay informed. Know what libraries and tools are available. Someone likened this to being a chef and not being aware of all the ingredients out there. And if any of you have watched Chopped or a show like Chopped, are we familiar with Chopped? Hopefully, I guess. Showing my the fact that I'm from the U.S. This is a cooking channel, and what the challenge is they bring on 3 chefs or 4, and they're given a basket, and they don't know what's in it until the start, and they have like 30 minutes to use that basket to make an appetizer, an entree, and then a dessert. And there might be badger, and cream cheese and a gummy bear. And that might be what you get to make an appetizer out of it. And the ones that generally do better understand some of the intrinsic properties of these foods. And they're able to whip something together into a cohesive whole. This is another example where if you're trying to do like JSON and you're trying to mess with web services, then C++ REST SDK, being aware that it's out there, will potentially save you a lot of time. Just like if you're unaware of some of the things Boost does, and Boost is pretty large, that's something that you may not have to reinvent the wheel. You can go out there and pull in one of these libraries. There's threading building blocks. There's also a list of C++ template libraries that are out there. There's database access libraries. Codeplex has a lot of things on it as well. There is just a lot of stuff out there. And again, I'm a community guy, and I've been doing this for a while. And what I find fascinating is it's pretty easy for you to figure out which one is potentially the most used in community, the most reputable, because a lot of these code repositories are backed by reputation systems. So I know that, for example, Jane, super C++ programmer, right, contributed to the library or contributed a library, and it's been evolved over time, and she's also been on the forums, she's given talks. So I can see in the profile the kind of activities they've done, and I start to get a good feeling about whether it's a reputable, good library or it's something that I might need to investigate a little bit more. And these are things you probably naturally do now when you're out. You're assessing whether a piece of content is reputable and actionable when you land on the internet or you don't, right? It's something that watching my kids grow up, the first time they got on, they know it's Sesame Street or not, right? I mean, they generally know what's reputable out there and what's not. It's something that evolves over time, and their skills are probably better than mine at sniffing out the bad, less than reputable. Keep an eye on the standards. ISO C++ is a place to do that, and then there are some papers out there about some of the emerging standards. If you're interested in this and the future of C++, I know that last year at Build, Herb Sutter gave a talk called The Future of C++. He flew down to Moscone, so I'm pretty sure he's going to be giving a very similar talk this year, probably on Friday. So again, in fact, I'm pretty sure that Herb will be streamed. So if you have an interest in the future of C++ and are just curious from a standards perspective and are a higher view, what things look like, then I would definitely recommend you tune in on Friday to that. And again, it's Build Windows. It's on channel, and I've got a link at the end. Follow the conversation. Guru of the Week, social media channels, email us. If you're on Twitter and you're searching for CPP or C++ or dev or something, it's kind of interesting. It'll eat a lot of your time if you're not careful. But I've seen some very interesting conversations just on Twitter about, hey, I didn't think this container did what it does, and this is how it does it. And then there's links out there that if you let yourself, you'll see what's going on. You'll also get a sense of who is working in what. Right? So if you're interested in learning more about getting into DirectX programming with C++, then you would know through social media that maybe Kenny Kerr is a good one, Michael McLaughlin. There's a bunch of folks out there that are kind of in different niches. You would learn more about that. I imagine most of you already know about the social part. And then reviewed written code written by others, and try something new. I know when I shared code and got the comments back, it was instructional for me and probably annoying to the people that reviewed the code, but a lot of people are going to be more than happy. Stack Overflow, I think, as long as you can share the code, right? I wouldn't recommend if you have company restrictions, don't just go share it out in public. You can share it internally, but if you've got an opportunity to share something and you're looking for like developmental feedback or just anything, it's like, hey, I'm doing this and this is how I implemented it. You'd be surprised at the quality of the feedback that you would get, all the way down to, well, why didn't you use Boost optional for that? And here are the pros and cons of using that, right? And it's a great way to learn. This is the last one. I'm a community guy, as I've said. I'm passionate about the community. I think that you should definitely be in the community. Connect online or in person. Share advice, experiences, and know-how. Definitely give back if you've, one of the challenges is there are a lot of lurkers in social, but sometimes it's harder to cross that line and contribute. Most of the people I talked to, in fact, everybody I spoke to before the session, you've got some experiences, maybe a lot of experiences that would be helpful, right? You can share even trivial things, and what you think is trivial is super helpful to someone else. So if you have an opportunity to answer questions on a forum or contribute to a wiki article or contribute to a code library, or make a video. Again, it might seem trivial to you, but it isn't trivial to someone else. And it doesn't have to be perfect, right? You don't have to write perfect English or Spanish or whatever language it is. You just have to solve a problem or share an experience. Engage with others and assume good intent. That assume good intent is difficult for people. It's something you learn in when you're young. But sometimes if you contribute code, for example, and then someone else checks in a change to your code, you might get a little bent out of shape. Where it's like, wow, I wrote that perfectly. Why are they changing that for loop and blah blah blah? But if you assume that people are doing it to help, for the general good, it makes life a little bit easier out in social land, right? And then don't assume good intent if someone proves you wrong, right? So it's almost a tit-for-tat strategy. Assume good intent until someone proves that you shouldn't, and then go from there. So this is another mascot, the dinosaur. I actually prefer the first one, but the dynamite and the shotgun or the machine gun. One of the other ones that really kind of cracked me up was there was a katana, but instead of having a handle, it actually had a blade for the handle. So it was a double-edged sword. You just cut yourself. That's what C++ developers are. That was pretty funny. So this was community generated. Here are the folks I want to thank for that. It wasn't me. I was more of a curator. These are the folks that helped. Some of these work at Microsoft. Some do not. So, for example, Billy O'Neill, Michael Blom, Michael Thompson. Some of these folks are on the user assistance team. They write our content, like Thomas Pichel, some of the others. Again, if you go out onto our sites and leave feedback, either the Visual C++ team will catch you, we'll look at it, or the UA team is going to catch it. Someone at Microsoft will generally catch it. Now, if you're an obscure site, it might be a little bit longer for us to find, but if you're in one of our forums or on one of our content pages and you leave feedback at the bottom, we're going to pick it up. James McNellis and some of the other folks, Billy O'Neill, I believe, are on Stack Overflow, along with a lot of other folks. So if you ask questions out there, you'll generally get answered relatively quickly. And thank you. And then here's the information I promised on build. So if you go to channel9.msdn.com, events/build/2013, that's where all the current information about our build event conference is going on. So, keynotes and things like that, some of the things are going to be streamed. These are the folks from the C++ team that will be speaking. Tarek is going to be giving a talk on Visual Studio from the C++ developer's perspective. Eric Brumer works in the compiler optimization, so he's going to be talking about performance at a very geeky level. Sridhar is talking about C++ CX and some do's and do-nots there. And then Herb, live stream on Friday, will be talking about looking into the crystal ball there. So I definitely recommend that you take a look at these. And if you're interested in the future of C++, definitely, again, take a look at Herb. So I'm speaking again Friday on DirectX graphics development. We will write a prototype. It's going to be in C++, not C#. I got nailed for that, even though I didn't promise to use C# at TechEd North America. We'll be using C++. And then this What's New in Visual, that's a hands-on lab. So if you want to mess around with a hands-on lab, and then around Visual Studio. And then you can find me later at the booth and online. I think that's it. Are there questions? Comments? I have shirts for questions. Comments? So these are Going Native shirts from last year. So if you want to, there might also be information about this. So if you watch it, does anybody know what Going Native is? So last year there was a conference in Redmond, and people like Bjarne Strustrup were there. It was very technical. 300 developers came in, and there was a bunch of very technical talks on C++. This is a shirt from that. So these are kind of exclusive. I went over and raided the guy's storage, and Charles Torrey stole these for you. When he found out who was going to, he goes, "Oh, that's great." So I've got these shirts. Any questions now? I know there was a question back there, so you get a shirt for sure. Yeah. Here. You want? There you go.
Okay, thanks.
Get this side of the room. Oh. Oh, right there. Oh. Thanks for coming.